Alright, this video is to remind you how to use the graphing calculator when doing calculus or pre-calculus for that matter. So we have a function, and I see this as an exponential growth function because the variable is an exponent. I need to know the number of leopards, which is what the function tells me, after 2 years. I need to know when the leopard population reaches 100, how many years does that take, and in the third case I need to know how fast, which is a derivative style question. So let's see how we would use the calculator to answer all of these questions. For starters, we have to make sure we enter in the correct function. So we have 10 times e to the 0.4x, which matches n equals 10 times e to the 0.4t. And then I need to create a viewing window, and one of the things I see in my question is 100 for the y values, that's the number of leopards, and I see the x's 2 and 3, not very large at all. So that tells me that I should select a viewing window that shows into the hundreds for a number of leopards, but not that many years need to elapse for that to happen. So I chose 10 years into the future to get up to 100 or 200 leopards, and when I hit graph just to see what it should look like, I can see all the interesting stuff is happening within my viewing window. By 8 years we've already exceeded 200 leopards. So as long as everything looks alright, let's answer the questions. And in the first case, the authors were asking for how many leopards are there after 2 years. So you can just go to your table. So once again, to get to your table, all you have to do is hit second graph, and that'll get you your table. So do that real quick. And it's going to produce a table of values that looks like this. And we can see that when t equals 2, that's the number of the population. So to get credit for this work, we show that we know how to use mathematical notation. We substitute 2 in for t, and we can evaluate 22.3. So it's about 22 leopards in 2 years. So we've more than doubled in 2 years, which is a very healthy growth rate. The next question is asking about how long will it take for the number of leopards to reach 100? The way that you do this is you go to the y equals, and under y2 you simply put in 100, which is the goal or the destination. So this is a changing population, and this is a fixed population at 100. So then we do second calculate so that we can find the intersection. And after we do that, we're going to end up with results that look something like this. So we can see here is what we enter, here's what the graph is going to look like, and then we hit second calculate intersect, and it will tell us the value of x that makes y equal to 100. So here's how we actually write the work after we transfer the graph to paper. We could show how to do this algebraically if you learned anything in pre-calc. If you can't do the algebra, you have the calculator, so there's 2 unique ways to get the answer to this question. You could use the algebraic method, or you could use the intersection on the calculator. If you have the calculator, you should probably use it. That's my logic. So it says in about 5 years, 9 months, so about 5.76 years is about 9 months into the 6th year, population should reach 100. So don't forget to answer in context as well. Part C, now we're actually getting to the calculus, and it said how fast is the population of leopards changing. I'll show you how to do this. We can just, first of all, we can clear out the 100, and then we go to calculate, which is right here again. And when we calculate, we're going to choose option 6 for dy dx. And as we wait for the graph to emerge, it's going to prompt us where would we like to find the rate of change. So I'm going to enter in 3 for the x value. Hit enter, and right here it actually tells me the derivative. So you can see right here dy dx equals 13.28 when x equals 3. It's the calculator is telling you the slope of the tangent line at x equals 3. So that's the answer is already given to us. All I have to do is write it. So once again, as far as notation is concerned, n prime of 3 is what I'm finding, and it's 13.28 leopards. And then leopards per year is a label. That's going to be the most important part. And the growth rate 3 years into this experiment with leopards was 13.28 leopards per year. So it's mostly calculator work and then a notation to answer in context. And then that's it. So I hope this was helpful, and Merry Christmas, Happy New Year, blah, blah, blah.